you will see 1.2 volt to 1.8 volt. Clear? We can bypass also. I will tell you later about this. Now let's suppose there is a 4G 3.7 volt. I'm talking about the water logging point. Sometime you will check here. There is a water, right? And you will measure there is a voltage here. A 3.7, let's say, take to 2 GPa, 4 GPa, and the APT. Why APT? I already told you. When we go to the far from the signal tower, two voltages, right? 1.0 and 1.8. Right now, this is L4 LDO, comes from the L4 LDO, and this one is come from the L1 LDO, right? In this at 1.8 voltage. Now, this line does not mean a 1.8 comes in at 2 GPa, right? This one is on a 1.8 voltage. The LDO number is different. VRAC, right? Now, we see all the RFFE lines. Let's say first our WTR or your trans receiver. Hello everyone, how are you all? Welcome back to the channel again. I hope all are good and learn something new day by day, right? Today in this video we discuss about the network section, how the network section will work, right? As you've seen in a thumbnail, we discuss a network section, especially on node service, right? How the network section work, what is the base, how the process, how to troubleshoot. All these questions, whatever that comes in your mind, you will see answer in this video, right? I'm always trying to give you good knowledge in a depth, right? With the full detail, right? In a proper way with the schematics according to the diagrams. So it will give you benefit, right? While you repair on your table, a fixing time, a mobile phone repairing fixing time. So I hope it will give you benefit, right? Now, thank you so much for your support and the love in comments, right, in my videos. Before going to the topic about the network section, I will explain to you how the network section works. One thing, many people messages me on a WhatsApp, right? Some want inquiry about the online training, right? They message also. The other messages come from my student and my members, right? Now, the subscribers is also messages me like a 40 form, right, for the guidance. I hope you get my point. But I have read all the messages, right, because there are plenty messages come to me. But my priority to come to my members and my students first, right? So sometimes I'm not giving the reply, right, accordingly, on timely, basically. But I'll give you a reply whenever I'm free, right? Second, so don't feel bad if you did not get a reply because there is a plenty work on my table. Also, there is a less time, right? Now, there's another thing. When you ask me for the guidance, right, ask me in a proper way, right? Now, what's the proper way? Like, if you ask, sir, this phone come to me in a dead condition, or this phone come to me, there is no light or no graphics. Tell you properly about with the testing details, right? If you tell me only this thing, right, how can I diagnose? I mean to say, how can I recommend to which line had a problem or which I see? Do you work, right? There is a process. Our testing, as you've seen in our videos, there is a process, right? Now, just like, for example, like a junior doctor, right, call to the senior, right, a senior level doctor, right? If they ask, right, about any patient, so there is a patient and this kind of the problem, can you recommend any medicine? So senior doctor ask directly, send me the reports, or diagnosis, or testing reports, right? After I'll give you a recommendation about the medicine, right? If you do not have a testing report, how can I? Simply logic apply on the digital devices like your phone repair. I mean to say phone or laptops, like these digital devices. Without testing, we did not give you a proper guidance, right? Also, it's depend on your testing, right? If your testing is wrong, the solution is automatically get. I hope you get my point. Now, in the today, as I told you, we discussed about a network section. So let's go to the circuit and how the network section work. Let's see. Now, in a network section, there are three types of faults. First one is a no network, right? When you see there is no signal on your phone, this is the signal, right? Like these are signal bars. When you see a crosshair or this symbol, right, on a signal bars, right, we call a no network, right? Or no, nothing, even not a single bar available here. Now, next, after that, the other one is called a low network. When you see the symbols, I mean to say the network bars, but there is a less bar, like a single bar or like a double bar. But when you go to just like a city center, the main town, right, you will see there is a full network, all right, a proper signal, right, a proper bars. And there is no problem between for communication and for internet, right? Properly uses internet and the communication. But when you came back to the home or go to the basement or like outside of the city center, right, from the city, you will see the signal bars, a one signal bar only, or sometimes a zero, nothing, right? So we call a low network, right? And the third one is like a network variation. You will see there is signal bar, a completely signal bar. When you try to call, right, it's a no network. Our bars gone completely. Or sometimes a call connected, but after a few minutes, thus these signals are gone properly after it's came back again. So we call it a network variation, right? So mostly for three type of the faults. Under three type of the faults, there are multiple faults, right? Also, for the repairing, I mean to say the diagnosis process, these three faults are like a different one, right? I mean to say, for diagnosis, these three faults, right? There are different steps, right? But the basic are same, right? So in this video, we cover basic also, right? So we clear this, and today we discuss about a no service. This under it, no network, right? As I told you, there is a no, right? A no service. Also, there is a call emergency. But today we discuss about this unknown service, how to troubleshoot this fault. Many technician, right, must have seen this. If one come to us with a no service, right? How to fix this kind of stuff basically. In this video, what are the basic steps? And so you get a good idea. Now, next, in a no service, you mostly heard that check the radio. Check the radio. First, check the radio is on or radio is off. So what is radio? Right? Radio is not like a FM, right? In this situation, it's not like FM, right? Radio is like waves, or you can say radio signals, a frequency, right? Here around us, there are multiple frequencies. So every device connected, I mean to say every device had their own frequencies, like your FM, right? Your FM work on like a 19 megahertz, right? Maybe a 105 megahertz. I'm not confirming properly for more confirmation. I'm just giving you a brief, right? That's why there is a channel like 91 FM, right? 92, 96, 102, like these kind of the frequencies, where you see a different type of the stations and different type of the programs, right? Similar, your mobile phone work on a different, your mobile phone on a 900 megahertz, 1800, 2100, 2300. There are a lot. As like we grow in the 4G and 5G, there are a lot of bands, right? Like your arm uses a different frequencies, right? So the radio is actually a frequency, a radio signal. It's not like a FM. Understood? So if your device, I mean to say mobile phone, right, is a radio off, in an off condition, there is a no service, no network, right? But there are some steps. When you go through it, these steps, you will see the radio is off or on, right? What is the condition? I will share with you steps also, right? Now, if the radio is off, so we work on a digital section, right? Basically, our protocols, right? In a mobile phone, in a network section, our protocol working like RFFC, radio frequency front end, right? As like I2C, SPI money. So these are protocols, but in a network section, this protocol works only RFFC, right? Now, if the radio is on, then we work on an analog section, right? Mainly, especially on a voltages, any voltage miss, or in a hardware chip, right? I will explain to you, don't worry. So we go to the next, and next, the radio off or on. How to confirm the radio is off or on. First step, a network type. When you go to the setting, right, in your phone, there is setting. When you go to the same section or network section, right, same or network. Every phone has a different firmware for different features. So when you go to the SIM or network, right, there is an option called a network type. When you open it, you will see there is like in a 4G example, 4G phone, 4G, 3G, right, 2G, and said it's like auto, right? After that, there is like a 3G and a 2G. These kind of the options in front of you, right? So when you switch from auto to 3G, it switches directly, right, without any error. And when you go to the back, after came back to the same feature, and it's still same. What are the changes by you? It's still same, like 4G to 3G. Then you go to the back, right? After came back, this is on a 3G. That is the signal the radio is on. It's a first condition, first confirmation, right? But if the changes, there is a tick mark, like if the changes, right, this tick mark is hide, right? Or the network does not switch from 4G to 3G, right? That means there is a radio off, right? So what will the impact? I will also discuss in this video and how to troubleshoot. Now after this, in the second step, there is a auto network in the network section, right? In the settings, also there is a auto network, right? Also like a carrier selection, like, so when you open it, there is a auto mode and the manual. So shift to the manual, from auto to manual. Now the searching start. If the searching start and the list generate, right, that means the radio is up, right? We work on it analog section, right? If the searching start after 2 minutes, there is no result, right? Still we see a chance in radio on. But by chance, when you shift to the auto to manual, searching just for after 1 second, there is error, can't search, right? Or any error, the searching stops suddenly after shifting. We call a radio off. So probably our RFSC protocols working not properly, right? So all these steps, or I mean to say work, we will see in this video. So don't to forget, watch it properly if you want to earn knowledge, right? Now after this, the third step, star has 4636 has star. This is the code. When you apply this code, there is another window open, right? In this window, there is a phone information, phone info. When you open it, there are multiple infos related to the network, so you other your IME also. There is another like a radio power. So you can see easily here on or off. So you can confirm it's a on or off, right, in this one. This code, sometimes some phones it's working easily, but some phone it doesn't, right? So there are two steps also. Now we go to the further. Now after this, for diagnosis, right, the mobiles, right, in the network section, there are multiple ICs, or multiple chips, or multiple filters. So what are the components? We just allocate. So first of all, the antenna, right? Second, your 2GP, or we call FEM, right? There is a 2GP, a 2G power amplifier, or the 2G network. Now the antenna is inbuilt, integrated before when the basic phone start, like a Nokia phone series, especially. The network antenna is separate. The power amplifier is separate. The network antenna is separate for receiving the network, right? Now, these two merge, right? The antenna merge in 2G, right? For receiving, right? How this is what we diagnose, how this is what we will explain in this video. Now, remember one thing, in this video, we did not cover the whole network because the network section itself is very long, right? So, in a single video, it's impossible to cover all detail. I'll give you some basic or important knowledge for 100% it will help you while you're the buyer. Now, next, a 4GPA. Everybody see in a 4GPA, right? Now, the 2GPA look like a square, right? But the 4GPA look like a rectangle shape, right? Both are power amplifier, right? After this, next is our APT-IC. A small IC. I will show you the motherboard also. A small IC, right? Now this IC give power to the 4GPA, right? Our 4GPA, right? To boost the amplification, right? Let's say you are outside of the city, right? There is a low network, I mean to say. Transmit the network or retain the communication, right? This IC gives the extra voltage to 4GPA. Either 4GPA had a 3.7 volt and the 1.8 voltage. Still, this IC or APT gives a external voltage depending on how much it's need. So this line has a 0.6 to 3 volt depending on needs, right? For a 4GPA, right? Now next, a DRX IC. Now this is small IC, like on the upper side, a DRX IC. So why this IC is tall, right? Because in previous, when the 4G phone launches, right? Let's say, you will see when a phone call come to you on your device, right? In a starting phone, right? I'm not talking about this another phone. I mean to say, our latest phones, right? When the 4G phone or 3G phone starts, right? What happens when a phone come to you, right? A call come to you, your network services are stopped. Whatever you're doing on a internet, they will stop, right? After the call cut, they will resume the services, right? But nowadays, when you on a call, there is a network, internet is also working behind your phone, right? So how is it possible? Because of the DRX IC, right? Now, this is you can call a second network IC, right? When the phone call comes in your phone, right? The internet services switch on a DRX through this, right? A communication with up through this IC. I hope you will understood. We have this. Now next, there is a CPU. So CPU is a master. So master is also important. But CPU communicate with the RFFE lines. Also there is other signal for communication, right? For through WTR, your RFIC basically, your radio frequency IC. But echo line also for RFFE, right? Through this line or other lines, right? CPU control the network section. So if any one of this line related to a CPU will damage or part, right? Your phone will no service also, right? Now, next one, PMU. So PMU is like a main power unit of your mobile phone. So the network section has multiple chips, like your 2GPA, 4GPA, your RFIC, your DRXIC, your switches, vents, filters. There are multiple. Every IC need a power to run. So your PMU create the power network section. If any line from outside of the PMU open, let's say, right, your network does not work. I hope you get my point. Now after this, there is a DPDT switch, tuner ICs, a small duplexers. These are sub ICs, or you can say filters, right? Now let me show you in a motherboard also. I know my lecture are little long and boring. So in front of it, this is the motherboard, right? So let me show you one by one. So this a sphere shape IC and 2GPA. It's also connected with the network socket, or you can say network antenna. You will see these this time, right? So easily confirm. We also call RFEM, right? Now this is our RFIC, transceiver IC, right? All these ICs work, and how to test it we discuss in this video, right? Now this one is called a DRXIC. This is also important part in the pairing. Now look at this. In a hardware solution, this IC does not even mention by the hardware solution. That's why we work only its wires. After this is the PME. These are all our basics one. And this one. This are for GPA, for amplifier, and this one, a small one, is our APTS. Right? I hope you get an idea. Now, what with the small of these small ICs? These are like filters or duplexers, right? So we tell you, we explain it one by one, each and everything, right? And we close this. Now, after this, this is a basic structure. There are a lot of lights more on this structure, but this is a basic structure. We'll work on it, right, in this video. How this structure work, what are the lines, how to test which line when introduce, each and everything, right? So stay tuned, right? Now, look at this diagram, right? There is a PMU, a 4GPA, RFIC, DRXIC, 2GPA, and the APTAs. Now, let's understand the power management of this IC. I mean to say this network section of power management. What are the power requirement of this section, right? Basically, our PMU is a power manager, right? It's giving power all of your motherboard through LDOs, right? Or secondary power, right? So first of all, the first one is a VPH, a 3.7 volt, 3.7 to 4.2 volt. Now this VPH comes from the charging IC, or you can call a DC to DC, right? Everybody know how the VPH generate, clear? So VPH goes to the multiple section in your motherboard, like your audio, Wi-Fi, Bluetooth, right? Like light IC, graphics, similar like a network section. Now in a network section, the VPH, right, or in a MediaTek we call a V system, right? Now this IC called 2GPA and this is a 4GPA. Both are amplifier to amplify the signal. So that's why they need a main power to run, right? That's why the power connected. Now this one is a little tiny IC called APT. I will show you in a motherboard also. Now these two IC is a PGIC. This one also a PGIC. Now PGIC, there are pins in outside, a little pins. You can measure the voltages and the diode value here. But this one is a BGIC, right? pole internally, right, attached. Now this small IC, there is a coil near about, and after the switching with the coil, this IC gives a extra voltage to the 4G PA, right? Now why? First of all, in this line you will get a 0.6 to, let's say, 3.2 volt and a variation voltage according to the need. Let's say you far from the tower signal, right, a network tower signal. Let's say you outside of the town, your city center, or in a basement, right, or in a traveling, right, for maintaining the communication, right, also the network services, internet services, your 4G PA need a more power to transmit the signal, right, as there is a 3.7 volt, but they need a more power. And depending on the situation, how far from the network tower signal, right? And okay, I hope you get it, because maybe a communication gap, some words could not understand, right? So this APT-IC gives the extra voltage. Sometime in this line you will get a 2 volt, sometime 2.5 volt, sometime you will get only a 1 volt, right? So I will show you also in schematics, right? But first we understand one or two lines. After we'll go to the schematics, and I'll show you in a motherboard also, right? So we clear this, and after next, now from a PMU, a line comes out, a VIU 1.8. Now PM generate lines called VDAC, right? VDAC voltages, LDO voltages. Everybody know the buck and the LDOs on a secondary lines. So in this line you will get a 1.8 volt. This is like a universal voltage. It's connected multiple in a motherboard, multiple ICs, right? It's connected. I will show you also. So these two lines are important one, right? When a phone come to you or for a no network, after the basic work, what I told you in this video, right? First measure these voltages on a 4GPA, 3.7 and 1.8 voltage. Similar like a 2GPA, right? 3.7 to 1.8. Now same in a APT-IC, these both two voltages, right? Now any one of this voltage does not connect, let's say open into the IC, your phone on a no network. Now sometime why I'm saying the open, because any one of this line, let's say a 1.8 line, if this line short, your phone in a dead condition, not in a network related, in a dead condition, because this is also a universal voltage. Similar like a VPH, this VPH is a main primary line. So if this line short, your phone does not turn on. So this line may be open. The reason of waterlogging, mostly chances in a waterlogging phones, the network area harmed, right? The water contact in a network area, due to the waterlogging, you will see most of the in a network section gaps from brown to dark brown or sometimes a black, right? Now I will show you in a schematic also. Now this is a motherboard, and we zoom it. Now this one is our 4GPA, and this one a small one, right? A little tiny IC called APT. Remember one thing, this IC is, I mean to say, through this line, this IC gives it to the voltage, and highly chances due to this line open, right? Your phone on a no service, there are highly chances this line open, most probably, in mostly cases, right? So near about these gaps, you will get this voltage, right? Most probably like a default voltage, you will see 1.2 volt to 1.8 volt. Clear? We can bypass also. I will tell you later about this. Now let's suppose there is a 4G 3.7 volt. I'm talking about the water logging point. Sometimes you will check here, there is a water, right? And you will measure, there is a voltage here, a 3.7, let's say this one is a 1.8 also available. Now, in your mind, the 1.8 and the 3.7 also the APT voltage. These three voltage, right, are clear. I will tell you later in this video, this voltages also I'll show you. Let's say in a 4G IC, these three voltages are clearly. But due to the water logging, sometimes this water internally, because this is a PGIC. So you will see these pads like a corrosion, I don't know the proper word, maybe. So this not connected a line from here, right? This gap to this IC is open due to water logging. There are highly chances. So this supply does not enter the 4GPA. You can measure here and you can confirm here. But if you did not check here, test here on these pads, due to this reason are not connected, your phone on a no service. So how do you test? For this there is a pads. So you can directly check on the pads, right? With the multimeter, you can take a knife, surgical knife, right? On the multimeter props attached or any needle, right? So you can easily connect here and check a diode value. If you get a diode value or voltage both, that means there is chances IC faulted. How? I will tell you. This is a process, right? So this one is a APT and this one is a 4GPA. Also show you in a 2GPA. Let's see. Now this one is our 2GPA. Clear? Everybody know? Now same two lines, a VPH and the 1.8 voltage is come here. Same rule follow here. Due to water logging, maybe a chances this line open from here, right? So check here also properly. Sometime we just working on ICs and forget about the basic work. The basic work is the most important, and your 50% work related, I mean to say, cover in basics, right? Now we go to the schematics. Now in the layout, now let's go to the 2GPA. Just copy this and paste in as schematics. Next. So this is our 2GPA. Now pin number 10 and pin number 9. This then follow, and you will see there is a coil. If this coil missing by chance or open, your phone does not in a no service, right? Or this is a VPH power. Just copy this. As I already told you, this line connected to many ways. I multiple ICs, as you know already. Now copy this. Now this line also connected to this IC is U2601 and this IC name is a 4GPA, right? I will show you in a layout. 2601, remember, right here, a 4GPA 2601, and the APT number U2900, right? So we go to the schematics and then next. Now this line also connected to the APT. There are multiple because we start from the network. That's why it's show the network ICs first. So this IC, this VPH connected to our 2GPA, 4GPA and the APT. Why APT? I already told you. When we go to the far from the signal tower, right, our 4GPA needs a more power to communicate, to retain the network services, right? So that's why this IC play a major role. Through this line, due to this line open, your phone on a no service, highly chances, right? Now we cleared this. Now let's focus on APT. Just a second. Sorry, 1.8 voltage. Now VREG L5 1.8. Remember 1.8 LDO 5. As I told you, this line comes from the PMU VREG LDO voltage. Just copy this. Now this line also connected to the multiple That's why I call a universal voltage. So if this line short, your phone on a dead condition or simple. But if this line open in a network section in any IC, like in a APT IC, it does not connect internally for a reason, right? Like in a series, any series component or any line open due to water logging. If this line open here or any component in a series like a coil or resistance, if this line does not enter or internally this pad does not connect or this IC faulty your phone on a no service, right? Now we clear this and we see next. So this one due to 7004 GPA. Clear? So same line also connected to the 2 GPA and the APT right here. This line also connected to the antenna point, antenna socket. This is our antenna socket, right? A 1.8 line, right? A VDAC. If this line, this resistance, there is an NC resistance, so not connected directly on this coil through. If this coil missing, right, your phone on a no service. Now where is this coil? L2700, just open and layout right here. This one. Let's see in a motherboard. There is any component. Yes, here. This one, a white one. Clear? Right? Understood? Now we go to the next voltages. Okay. Now after this, there is another voltage from PMU connected to the RFIC, right? Or WTR IC, or transceiver IC. This one is our transceiver IC, main RFIC, right? This one is a main network IC basically. From a PMU, a 1.8 voltage, right, for RFIC, right? Now, after this, there is another voltage, a volt called 1.0 volt, right, for RFIC, right? Now 1.8, 1.0, sorry, this one is a 1.0, right? Now after this, there is a frequency from a XO, from a PMU, a radio frequency, right? Or a frequency from the PMU. This is a signal like a frequency, right? Because your RF work for the radio frequency, a communication department, handling the communication department. So PMU gives a frequency for manage all the communication. Now in a PMU near crystal, right, connect with the PMU, give a voltage to the crystal. After crystal, give a frequency to the PMU. After PMU, amplify this frequency and distribute like your RFIC, also your SOC, right? So this frequency is also most important. I will show you in a schematic. Many technicians did not test here at this frequency. If this frequency also disconnected, right, your phone on a no service, right? So let's we go to the schematics, and after I will explain you all these things. So we go to the Borneo. Now in a Borneo, let's we go to the first copy directly to the RFIC. This one is a RFIC and paste, right? Now zoom. Now B and A, right? Already explain you in a video. This one, a last digit is a block like 1, 2, 3, 4, right? If it like IC had a 6 blocks, so maybe a 1, 2, 3, 4, 5, 6, maybe A, B, C, D, E, F, like this. So there is A and B, right? If we click next here, just a second, only A and B. So this WTR IC, I mean to say this RFIC, had 2 blocks, A and B. So let's see the voltages. So this one, a DIG, right? Right, there is a 1, 2, 3, and 4. Now copy 1 and then next. Now this line comes from VRAC L1, LDO1, 1.0 voltage. Remember, Now this line enter in a 3 ways, right? Enter in a 3 ways. All 3 ways had a resistance in a series, right? Like this one is a RFIC, and these are the poles, right? So this one and this one and this one. So 1.0 volt connected here, also connected here, and connected here, like this. By chance, let's say if this resistance is missing or open, right? So this line is open here. So in case when you check here on these capacitor, let's say you test here on this capacitor 1.0 volt, you think there is a 1 voltage here, but if this voltage does not connect internally on IC pads, right, then your phone on a no service, right? This is our DIG voltage, a digital voltage basically. Now this line comes from I will tell you about this line later, right? More explanation, actually an advanced one, right? Now there is another voltage, another line, right? Now we see this line. First we clear this line. I hope you get it. There is a L4. Now this is a 1.8 line. As I show you, there are two voltages, right? 1.0 and 1.8, right? Now this is L4 LDO, comes from the L4 LDO, and this one is come from the L1 LDO, right? In this at 1.8 voltage. Now this line does not mean a 1.8 comes in at 2 GPa, right? This one is on a 1.8 voltage. The LDO number is different. VRAC L5, I think I'm correct. Now this one is L4. So both LDOs are different. From PMU, this line separately gives to the RFIC, your transceiver IC, right? So if anyone, this 0 ohm resistance by chance open, your phone or no service, let's say this resistance is missing or open, you can directly jump it, no matter, because this one is a 0 ohm resistance, right? Now we go to the again IC, right? Now there is another, let's see the U2500. There is another block here. This one. Let's type here U2500. Next, a B block. We go to the A block right here. This one. So there is a, you will see MB1, HB1, so higher band, a medium band, LB1, a lower band. We talk about later. Now there is a XO, right? When we copy this and then next, now this line also come from WTR clock signal. This one is a clock signal. Now capacitor in a series, right? Capacitor in a series. Capacitor block the DC voltage and passes the frequency. That's why in a series, right? Clear? Copy this. Next. Now this line come from a PM439 housekeeping department, right? H key goes to the WTRIC or RFIC. I hope you get my point, right? Go to the clear. So in this line, you get a frequency, right? Let's see there is any component in between. Now there is a 3 line connected here, like this. Any one line of open, there is a no service, right? Let's see one time schematics again, and frequency line, anything. Right here, right, this one. There is a resistance 220R, 200B, right? 220 ohms. Also a capacitor, cap, right, in a series. I hope you get my point. If this capacitor also missing, because this one is a series. So series component is mostly important, right? So if this component is missing, right, your frequency does not passes into RFIC. So your RFIC does not trigger, right? So hope you get my point. Now we go to the next. Clear this first, and now after this, the DRXIC from PMU, a line goes to the DRXIC, a 1.8 voltage. Now, what is DRXIC? After we talk about this voltage, already explained in this video. This is like a secondary diversity receiving. So when your phone on a calling time, I mean to say when you talk to the someone, right, in a previous, like in a 3G phones, in a starting era, in a 4G phones, you will see when you talk to the someone, right, behind the internet services are closed in your phone, no messages in a WhatsApp, right? If you watch the YouTube video is also post. But nowadays, each and every phone had this IC. So when you talk to the someone, right, you can use the internet services also, because internet services shift on DRXIC, right? Your secondary. Now this IC needs also a voltage to run, right? A 1.8 voltage. Now second, anything more? Let's see. There is another voltage called 2.7 volt. So let's see in schematics these two voltages and how to test. Go to the right schematics, just open the layout, and this one is also a PGIC U2801. Just copy this IC, simple, and paste in schematics. You can test here easily each and every pin right here. Like a DX, you will see a band 7, band 1, band 3. So these are bands, right? B4, B7, B38. I will tell you later about these bands, right? I'll only give you what are the necessary information to you, right? In a practical time, I mean to say, in a repairing time, it's uses most. If I'll talk to the band system, that yes, it's a technical points, right? So you think I'm a genius if I'll give you a band's knowledge, but if you on a while repairing, this band system does not work. It's just like for the information, it's used. It's a good information, but it's used in a like for the interviews, like in big companies or impress to someone, right? But in my career, this band system does not help me a lot on a practical time, on a repairing, because I'm not running an institute. Basically, I'm running my shop, right? I'm working for other shopkeepers. Like basically, my work is for dealers, right? Dealer shops. Actually, whatever the phone comes in my shop comes from the another shops or dealers, because we work in a chip level, properly in depth. So whatever they did not repair, they give it to me. So that's why I know what's important for you. So we see a VRAC L5 1.8 voltage. Oh, this L5, remember, this one is the same. Now, look at here. Now this line connected to the 2 GPA, 4 GPA, maybe in a drawing for the space, less space. So maybe in a less space, I do not draw properly. But this line connected to the 2 GPA, 4 GPA, also APTIC and the DRX, right? So come from the L5. So if this line also did not connect, right, internally the IC pads or IC voltage, your phone on a no service. I hope you get my point. Now other one is L18, LDO18 or 2.7 voltage. This is also a most important voltage. Let's see. Now when you see in a hardware solution, these voltages multiple, right? Multiple data does not complete on the hardware solution, right? So these anyone think these capacitors, you can measure on these capacitors here, right? So we go to the component section, and this one is this one, right, is a DRXIC. This is also important, right? I hope you get my point. Right now, after any other voltage requirement, I don't think so. After this, let's say a APT, right, or this one, a blue one, right? I'm already explaining you this line, right? In this line, you get a 0.623 volt roughly for a 4 GPA, right? Not here, only a 4 GPA connected, right? Already explained, right? So this line, mostly cases you will find in a damage due to this line on our service, right? Now next, just a second, clear this. After this, there is a protocol. Now start the protocol or communications, because in our network section, right, RFFE, just a second. In a network section, this protocol used called RFFE, radio frequency front end, right? SDA, SCL. In a power section, like in other sections, you will see like SPMI, SPI, I2C, right? In a network section, whatever the phone, you will see the RFFE, a radio frequency front end, right? So these are communications. So CPU communicate with this IC called transceiver IC, your main IC, right? Right. Now we see all the RFFE lines. Let's say first a WTR or your transceiver IC in schematics. After we go to the another. So we copy here your RFIC and paste in schematics again. So this one right here. So these DIG and transmitting, receiving, all line clear, our voltage lines. Now next, now this line, you will see there is a RFFE, clock and RFFE data. When you copy this line comes from the GPIO, your SoC CPU, right? This line directly, any component in between them, no component. So how do you confirm this line is okay or not? Because if this line is also open, right, anyone, even a clock, even a data line, anyone, both of them, right, so your phone are in no service. So how do you test? For this, you remove this IC, right?
We have it.
Remove this IC. Clear? After this, when you remove this IC, there is a pads. So check the pad number 47 and the 55. If you get a diode value on these points, right? So that means your CPU connected here. Is any line open? Well, that means the problem is for, then you can revolve, the CPU. Now when you open the WTR, right, your transceiver IC, you also check these lines, these four lines also are communication lines, right? QP, QM, IM, right? Now these lines also come from the CPU, right? Any one of these lines, your phone or damage, no service. Clear? So go to the, so I did not show all these lines, QM, IP, IM, like this one, like this. All right. So check 6 lines when you remove this transceiver IC. Eventually you test all the pads one by one. So if you test all the pads, if the fault through any pad or any IC, other IC, your mind will be clear. Otherwise, replace the RFIC. Right? Now, next, after this RFFE line connected to the 2GPA, 4GPA, similar to the APTIC. Right? Right here, right here, right here. SCL, SDA. Right? Now, so this is also an important line, RFFE lines. First check the diode value here, right? So next, after this, the CPU communicate with the DRX IC also. These are separate, right? This one is separate. Now these communications, T3 IC communication together, but the transceiver IC and the DRX IC are connected with the separate balls, right? I hope you get my point. Let me show you in a schematics. The video is already long, right? So we go to the layout and 2GPA. First we show you a 2GPA. So there is a RFFE lines, RFFE clock data now connected to the, this one is our 4GPA before the 2GPA, and this one is your APTIC, clear? And this line connected to the GPIO section, right? Okay. And now we go to the layout and the DRX IC. Right here. So there is RFFE lines and in this one, like here, connect here directly to the GPIO section. Clear? Now we go to the, now after this, there is another line. Many technician does not know about this line, right? Now when the antenna connected to the 2GPA, through 2GPA, a line connected to the your RFIC with a SPDT switch sometime called CPL, right? Let me show you in schematics. After I will explain to you. So we go to the directly to the antenna, copy this antenna. Let's say copy this 2GPA, right? So this one, this is our antenna line, right? Main antenna line, right here. So when this line connected to the antenna, I mean to say this IC, to recognize which bands working, I mean to say for the working, a line called CPL out, right? If this line damage or this antenna line damage, their phone also on a no service. There is a multiple component like a capacitor and resistors in a series, right? Now when you go to the next, right? Now this line connected to the WTRIC, right? Called CPL. Right here, get back to the right here. So if this line not connected, right, to the 2GPA, your phone on a no service. So let's clear this. So I hope you will enjoy this video, right, and learn something new. For the upcoming videos, I will show you how to test in advanced level when a phone come to you, right, if for network section, right? Most probably for this information, you will test and repair some phones, right? For the advanced level, you can contact us or wait for the videos, right? If you want a good training, right, a good knowledge about the schematics, if you want to answer for the circuits, how the circuits work, right, advanced knowledge, right, then you can contact us on this number, right? And we provide trainings, online trainings, right? So we will meet you in a next video. If you like this video, then share and comment a lovely comment. So this comment and the like motivate me to make more content for you. Meet you in the next video. Thank you so much for your love.